the charge which is given will come settle here. This will be minus q, this will be 0. Agreed? Now, what about the field inside the conductor? We'll show the direction. So there'll be a uniform electric field is this will be the field. I'm interested, let this be point A, B, and let this be C. And anyway, the point P will write it. What about field strength at point A? What all charge given, where do it will go in settle here? No, sir, why not Q1 and Q here? No, from the Gauss law. No, everywhere here. So what is the expression we give whenever plates come? Who's help? The Gauss law. We just say, okay, due to Gauss law. Fine. Look at carefully. So Q minus of minus Q will become 2Q. 2Q by 2 will be Q. Then the charge on these faces, opposite faces, should be equal and opposite. And charge on external faces should be of same sign and same magnitude, 0 and 0. Now, field strength at point 1. The field strength at point is calculated by here Q by A 2 epsilon naught plus Q by A 2 epsilon. How much it is? Q by A epsilon naught. What about field strength at point? Again, if you are really thinking, give name like this. Field strength at point A will contribute by 4 and 5. That's what I did. And what in fact, it will produce field like this, no? All of you, please think minutely, because this is what the concept we needed for the next chapter. So in the books that is given, the way I'm telling, a lot of difficulty. Okay, avoid this. Let's go back to the basics. The field at point A all will contribute. 2, 4, 5, and 7. Due to 2, it will be 0. Due to 4, charge density is how much? Q by A by 2 epsilon naught. Because each face of a conducting sheet, each surface of a conducting sheet will behave like a non-conducting sheet. Charge is present only on one side, no charge. So though conductor, so what actually? It is made up of 2 non-conducting charge sheet, the assumption. A charged conducting sheet, what you should assume? We should assume it made up of 2 non-conducting charge sheets. Finish over. So though it's a conductor weapon, we are treating it like this is one non-conducting sheet. This is one non-conducting sheet. Now what is the direction? Towards. Then this will be Q by A. This is a method. Similarly, field strength at point B. Who all will contribute? 2, 4, 6, and 8. Due to 2 will be 0. Due to 4, Q by A. Due to 6, it will be minus I cap. Why minus I cap? At B, the 6 will the 6 will contribute, and look at the field now, it is towards left, so minus I cap. So this will be 0. Similarly, at C, we'll see. At C, we will contribute 1, 3, 5, and 7. Let's get into the calculation part. Now, this will be 0 due to E3. Due to E5. This will be more confusion. So like there's a positive charge, you put negative sign, negative charge, positive sign. Already the direction of field, keep looking at the charge, the direction of field is indicated. Looking at the charge, the direction of field is indicated. Here what will happen? Based on the direction of field, we are giving the sign. Am I right? So where the field is only confined between the plates here. So let d be let small d be the separation between the plates. Let A be the area of cross section. Let's write that also. Area of cross section of plates. Then what is the volume between the plates? Equal to like A into D. So is there any electrostatic field energy present? Yes. So we'll introduce that also. The electrostatic field energy between the plates. This should be equal to energy density into volume. Can you remember in elasticity, we defined this one, energy density. Similarly here, electrostatic field energy per unit volume. So the symbol will be UD into volume. What is that electrostatic field energy? Energy density. The energy density is given by of epsilon naught E square. How much of electrostatic energy per unit volume? What should be the unit for this? Joule per cubic meter. So therefore, this will be half epsilon naught E square. What is the volume? Volume of this will be A into D. Do we know electric field between the plates? It's the EA, no? What is the field strength here? It is equal to EA. So EA equal to how much? Q by A epsilon naught of epsilon naught Q by A epsilon naught whole square A into D. So solving this, Q square D by 2A epsilon naught. So this is the energy stored between the electrostatic field energy stored between the plates. Capacitor is over. The capacitor chapter gets over. Okay, there's a one formula I introduced, this one called as energy density, which is equal to half epsilon naught E square, electrostatic field energy per unit volume given by this one. If you know energy density, use this formula. Now, if the electric field is uniform, what you are going to do? Directly multiply energy density into volume. If the electric field is non-uniform, then in that case, what we are going to do? We are going to assume an elemental volume. First, we'll find out how much energy in that elemental volume. Then we'll integrate, we'll get total energy in that particular region. Okay, what was the condition? The plates are given equal and opposite charges. Okay, let's try another conditions. If I give some